As part of the Signpost programme on tillage farms, we're going to look at soil quality. One part of that is to try and see what stresses the machinery is putting on the soil. To do that, we need an estimate of the axle loads, the loads on the wheels and tyres of the main machines on the farm. And this short video really is just to help you to actually do that, to calculate that, or to give us the figures, and we can then actually calculate the stress from that. So what it involves is a weighing of machinery, if you have access to a weighbridge, and to do it on an individual access basis. If you haven't got access to a weighbridge, we can do it actually by taking standard weights, but also by estimating where the loads are on the axles and so on. So there's a way of doing some dimension, or collecting dimensions for doing that. So Brendan Burke and myself and some of the lads here at Oak Park put together this very short video just to help in doing that. The information that you gather then, you can jot down on a form, get them back to us here in Oak Park. We can then work through those, calculate the exact loads, calculate the inflation pressures in the tyres, the relationship between the tyre size and the load, and most importantly, we can make an estimate of soil stress from these loads, and then we can see where that lies, in terms of whether it's good or bad, or action needs to be taken or not.
So the first option is to directly weigh the actual axle loads that we're interested in. So if you have access to a weighbridge, this is the easiest way of doing it. First thing to do is to record the tyre sizes of all the tyres that are in question. Record the tyre pressures. It's easy here in the photo where it's on the outside. It can be a bit more difficult on the inside, but again, it's useful information to us. And then if you have or if you have access to a weighbridge, either your own or a local co-op or whatever, then to weigh each axle in turn. So this is just getting the front axle here. There's 4.12 tons in this case on that front axle. And to record that then in the sheet, we'll provide sheets for doing that. And then to move through, we're not so interested in the total weight as the individual axle loads, but again, to get the rear axle load with whichever implement is there. In this case, that's 6.6 tons. So you can see in this case of the tractor here, we have 6.6 tons in the back. Remember, there's no seed now in the hopper there, and less on the front. Sprayers can be quite heavy. This one here, rear axle load, 1200 litre sprayer, 24 metre mounted boom, quite heavy. Plough, again, as long. So the front axle, 2.3 tons, but the weight of the plough isn't huge, but it has length at the back. So it's acting back quite a bit back. So it takes a lot of weight transfer from the front of the tractor, and you're going to end up with a total load of about 8.1 tons, 8.2 tons for that 5-hour plough on that size of tractor. Okay, so that's if you have access to a weighbridge. If you haven't, the options are to do some measurement, and we'll estimate from standard weight figures then what weight is actually on the different axles. So we go about by setting out the 2 ranging poles here just to give us a marking point for the center of the axle. So in this case, we're actually just going to measure the wheelbase of the tractor. Now we can get that probably from a book as well, the wheelbase, but it might be as well to measure it. And we're also at the same time going to measure the distance from the front axle to the center, where we think the center of gravity of the front implement is. Okay, so in this case, it's round about the center of the packer roller there. So we have a distance here of 2 meters. So we'll record that 2 meters from the front axle to the center of gravity of the front implement. The wheelbase itself being measured here. In this case, as I say, we can get it from a book either, but in this case, we measure there's 2.85 meters here. Okay. The next part's a little bit more tricky. We're trying to estimate where the center of gravity of the implement is, and where the implement is a tank, we like to do this in 2 separate ways. There's a seed hopper or seed tank on this. We'd actually measure that separately. But first of all, just to try and guess where, I suppose, the center of gravity is by looking at where you think, if you were to lift that with a crane above it, where you'd put a single hook so that it would remain steady. That's what you're trying to estimate. So look at the weight of the packer, look at the weight of the power hour, look at the weight of the drill, and how far the different elements, the coulter bar going out the back and so on. So that's the distance we picked here, and it's been measured at 1.9 meters from the center of the axle. So that's the center of gravity of the one pass back. Plough can be a bit confusing. Okay, a plough is very long. This is a 5-hour plough. It's a big distance back, but the center of gravity is a bit closer to the tractor than that. because it's generally a little bit more to the front, because the headstock and frame, if you look back here from the other side, the headstock is heavy, the frame at the front tends to be a lot heavier. It's doubled up in a few places there. So that brings the weight a bit more to the front, but it's still a distance back from the rear axis of the tractor, as the two ranging poles will show you here. So again, it's difficult to estimate, but if you can do that for us, give us an estimate of where it is, that'll be great. All this has helped you a lot by taking pictures. In this case, by the way, it's 3.25 meters. So we would ask you to take pictures of everything in that way. It's also useful to get the weights on some implements. It's pretty easy. That front packer there is 1.4 tons. You can see the plow figure here, but the plow is a bit more difficult because it depends on the equipment put on it. But there's a plow weight there in the middle. The front weight in the tractor there, 900 kilos. But as I said again, take pictures of the machines and tractors. And again, we can do a lot of estimation even from that, a lot of information coming from that. So that's more or less it.